Good morning, class 10. Today we are going to read first chapter of physics, and the first chapter is force. We have already studied about the force. Force is an external event which changes or tends to change the initial state of a body. And for this the force has to do two main works: pull and push. Now, for example, when magnetic force is used, a magnetic substance is pulled toward the magnet. Two charges are attracted or repelled. Attracted means they are pulled, and repelled means they are pushed together. Similarly, centrifugal force pushes a body away from the center of a circle, moving center of a circle. When a body is moving in a circle, the centripetal force pulls a body moving in a circle toward the center. So we see that any force has mainly two works, that is pull and push. Okay. Some examples of force you can write. Some examples of force: magnetic force, electrostatic force, static force, centripetal force, centrifugal force, gravitational force, etc. In class 10, we read about the gravitational force in detail. Okay? What is gravitational force? Gravitational force. Before starting this gravitational force, let us know something more about the gravitational force, history of gravitational force, some observations made by scientists. Okay, gravitational force before 1542 AD, it was believed that the Earth is at the center and the Sun and other planets are revolving around the Earth, and that was known as geocentric theory. In 1542, Nicholas Copernicus told that not the earth but the sun is at the center, and all planets are revolving around it. In 16th century, Galileo, by his telescope, observed the planet Jupiter, and he found that 4 satellites were revolving around the Jupiter. He further supported the idea of the Nicholas Copernicus, and then it was believed that actually the sun is at the center and all planets are revolving around the sun, and satellites are revolving around the planets. In 1687, Newton was thinking about the force of gravity, was thinking about the revolution of the planets around the sun. Why the planets are revolving around the sun? He observed an apple falling toward the earth. From that phenomenon, he concluded that the earth is attracting any body towards its center, and that is called force of gravity. Further, he concluded that the earth and other planets are revolving around the sun because of the force of attraction between them, and then he called this force between the planet and the sun as force of gravitation. Finally, he concluded that not only the sun and the planets are attracting each other, but any two bodies in the universe are attracting each other with a force which is called gravitational force. Okay, that's why gravitational force can be defined as the force of attraction between any two bodies in the universe towards their centers due to their masses is called gravitational force or simply gravitation. Okay? Then Newton devised a law about the gravitational force, and that law is called Newton's universal law of gravitation. Now we write Newton's universal law of gravitation. It is universal law of gravitation. It is called universal law because this gravitational law, this law is applicable between any two bodies in the universe, whether the bodies are microscopic or massive, whether they are placed on Earth or anywhere in the universe. Okay? According to Newton's law of gravitation, it states that the force of gravitation between any two bodies in the universe is directly proportional to the product of their masses and inversely proportional to the square of distance between their centers. Okay? From this law, we understand that if mass of two bodies or any one of the two bodies is increased, then certainly the product will increase, and hence the force of gravitation between the two bodies will increase. From the second statement, we understand that if the distance between their centers is increased, the force of gravitation between them is decreased. Okay? Let us explain it in this way. This is a body of mass m1, this is another body of mass m2, and they are placed at a distance d away from their centers. Okay? This m1 attracts this m2 by force F. This m2 also attracts this force by the same. This m2 also attracts this mass by the same force F. Okay? According to the statement, we can write, let us consider two bodies of masses m1 and m2, placed at a distance d away from their centers. Okay? Then the force of gravitation between them can be written as, according to the statement, m1 into m2. F is directly proportional to m1 into m2, and F is inversely proportional to a square of the distance between their centers. From this statement, we can say that if mass of m1 or mass of m2 is increased, or mass of both are increased, masses of both are increased, certainly the force will increase. Similarly, if the distance between these two bodies is increased, the distance between these two bodies is increased, the force will decrease. But how the force will decrease? In square of the distance. That is, if we increase the distance between these two bodies by 2 times, certainly the force will increase by 4 times. If we increase the distance between them by 3 times, certainly the force will decrease by 9 times. Okay? If we reduce the distance by half, that is, if the distance between them is halved, the force will increase by 4 times. Okay? Now, we combine these two forces, these two relations. Okay? Combining these two relations, we get F is directly proportional to m1 m2 upon d square, and we have to reduce this proportional constant by putting a constant g m1 m2 upon d square. This is the third relation. Okay, where G is a proportionality constant, and is called universal gravitational constant. Henry Cavendish found its value, means that is value of G, as 6.67 into 10 to the power minus 11 Newton meter square per kg square by using a torsion balance. The value of G is very small. Let us see here. The value of G is 6.67 into 10 to the power minus 11. That minus 11, 10 to the power minus 11 makes the value of G very small, and hence the force of gravitation between two bodies becomes very small force. And that is why when two bodies are placed certain distance away from their centers, both of the two bodies are not being noticed, they are not being moving towards their center because of the value of G. Okay? Because of the small value of G. Okay? Now, we can define G, definition of G in terms of force of gravitation. Okay? If m1 equals to m2 equals to 1 kg and d equals to 1 meter, then F equals to then F equals to G1 1 upon 1 to the whole square equal to F is equal to G equals to 6.67 into 10 to the power minus 11 Newton. Thus, G can be defined as the force of gravitation between two bodies each of unit mass separated by unit distance away from their center. Okay? Let us take an example. Example of the calculation of force of gravitation between two bodies. Suppose these are the two bodies, M1, this is of 20 kg and this is of 80 kg. So it is 100 kg suppose, and they are placed very close to each other. Okay, suppose the distance is 1 meter. Okay, now this 100 kg is pulling this by force F, and this 80 kg is also pulling the 100 kg mass by force F. And how will we calculate the force between these two masses? Here M1 equals to 100 kg, M2 equals to 80 kg, D is equal to 1 meter, and we know the value of G is, and G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, then F equals to 6.67 into 10 to the power minus 11 into M1 is equal to 100 into 80 upon distance is 1 to the whole square. Okay, on calculating we get 1, 2, 3, 10 to the power minus 8, it becomes 8, 7, the 56, 6, 8, 6, 48, plus 5, 53.5, 8, 6, 48, 48 plus 5, 53.36 into 10 to the power minus 8 Newton. Okay, we see that this is very small force. We can we can write it in decimal like this: 0.0000000. F is equal to 1 2 3 4 5 6 7 that much Newton. And this is very small force, and because of this small force, these two bodies are not moving towards each other, because this small force cannot create acceleration in these two bodies. Okay, and now we read about effects of gravitational force. Okay, presence of air or atmosphere on the earth is due to the gravitational force of earth on air particles. Okay, we can construct buildings. Some effects we can write here, some effects. We can construct buildings on the earth because of the, due to the gravitational force of the earth. Similarly, when we throw a stone upward, it returns back to the earth due to the earth's gravitational force. Okay, tides occur in ocean and seas due to the gravitational force of the moon and the sun on ocean water. Okay, and etc. We can write we observe many effects of gravitational force in our nature. Okay, now how does the distance and the mass between mass of two bodies affect the force of gravitation? Okay, for today we read up to this. Okay, and we will discuss about the factors on which gravitational force depend, okay, in next class. Thank you.